for today's agenda, so we are going to discuss three concepts, guys. So first thing is the continuous, configuration management. So I hope you guys are seeing last two theoretical sessions, correct? And second one is, we will go for the. So first thing is the configuration management and continuous monitoring. And third one is the necessity of the cloud. So the necessity of the cloud and the cloud computing models. Okay, so these three concepts, so we are going to see for today. So coming to here, guys, so the configuration management. So what is the meaning of configuration management? It's purely the configures the servers. Okay, let us assume, so I have 5 servers. Let us assume, so I have 5 servers. Server 1, server 2, server 3, or server 4. Okay, due to the fine. So let's suppose, so we have these kind of servers. Now what we can do? So I want to install some kind of configuration. Okay, so I want to install some kind of packages here. So let us take, so these are what are the packages or what are the tools we need to install here. So let us take, so this should be Java and Tomcat, Maven, web server like HTTP, and we are also one more web server, Nginx, and we have the database DB. So let's say the Oracle. And we have the some kind of certificates, and we need to git. Let's say we need to install the Docker or etc. Okay, so these many tools we need to install. See guys, whenever we are using the organization level, okay, so we need to make sure to use some kind of tools. So if you want to install them these kind of tools, so we need to do manually, correct? We need to go for the manual process. Need to go for the manual process. Suppose if I want to do, let me do that 1 minute. Yes, okay. So if I want to install all kind of software into these servers, so how much time it will take? Can anyone tell me? Chandra, can you tell me? So how much time it will take to install all kind of softwares here? You got my point? So we have the 4 servers. Within the 4 servers, I want to install Java, Tomcat, Maven, HTTP, Nginx, the Oracle, some kind of access. Let us say we have the 10 softwares are required. So while we are using our application, so how much time it will take to install all this configuration?
I think 4 or 5 hours.
Yeah, let us assume. So instead of that, let us assume 2 hours or 3 hours. Okay, 2 to 3 hours, right? So for one server, we are having 2 to 3 servers, and again we are having 2 to 3 servers. Let us assume right now we are not having 4 servers. Right now, so we are having 20 servers or 100, 200 servers. So can you think of it? Is client will accepted that much of time? Is client will accepted that much of time? So only to configure those resources.
No.
Let us assume for 4 hours, for four servers, we are having 8 hours time, correct? Let us assume if every server is 4 hours. Let us assume for 100 servers, so 100 into 200 hours. Is client will happy for to spend this much of time only for the configuration? See, if most of the time in organization level, so the people are thinking about the development. The people are thinking about only for whether the future is working or not. But instead of that, so we have to make sure to configuration of the resources. So without any software, are you guys able to do that? No, correct? So without any softwares, you guys are unable to do that. So in that scenario, so how we can able to handle the things? How we can able to handle the things? So this is very important, right? So here the DevOps engineer will come into the picture. Let us assume if you are writing any kind of script, so maybe we can reduce time from 2 hours to the 1 hour. Okay, that but still that is a manual process, guys. Still that is a manual process. So in that scenario, so how we can able to handle the situation? So the DevOps engineer will come into the picture. So they can able to do some kind of orchestration. Orchestration is nothing but a cluster. Okay, a group, whatever the servers are available, all the servers they can able to combine into the cluster. So this is called it as a cluster. So for this server like this, okay, yes. So this is called as a cluster. You got my point? So instead of that, we can use some kind of infrastructure as a tool. So IOC tool. So that is come under DevOps. So in this DevOps side, so they can use the most important tools in the market. So earlier days, the people are working on the Puppet. Sorry, first one is Chef, Puppet, Ansible. So out of these three tools, the Ansible is very powerful, guys. Ansible is very powerful and it can be supported. So thousands of modules. It can be supported thousands of modules. Now here, what will happen? So the orchestration is nothing but this is a cluster. A cluster is nothing but to combine group of nodes. To combine group of nodes. The cluster is nothing but to combine group of nodes. So what will happen when we are making into one cluster? So we can just configure all these configurations into the master node. So let us take this is the master node. Master node is nothing but it is only helping for our internal. We can connect with all these servers. Okay. So this is very important, guys. So whenever we are working on that, automatically, so the cluster will enabled and we need to use some kind of tool. So instead of doing manually process, we are using some kind of scripting. We are using some kind of scripting here. We are using some kind of scripting here. So which kind of script we are using? So that is IOC kind of script. So if you take Puppet, if you take Ansible, okay, the Puppet is using the Puppet TSL. If you take the Ansible, so this will help us the YAML file. Okay, so they are using some kind of YAML. So within the YAML configuration, they just configure the configuration. So here, how it should work now? So I'm gonna write some kind of script, a sample script. So Java, which version 1.8, Tomcat, which version I can use. See how it look like the this is like this only. So Java 1.8. So this is a just like a infrastructure as a code kind of scripts, guys. Java 1.8, and if you take the Tomcat 8.x, and if you take the Maven 3.x, and HTTPD 1.x. So this is the version, guys. Okay, Nginx 3.x, okay, etc. So whatever the softwares, whatever the configurations we required, so all the configurations we need to configure, all the configurations we need to configure. So this is very important, guys. Okay, so whenever so we are using here, so we are using some kind of tools, infrastructure as a tools, infrastructure as a code tools. This tool will automatically, when you execute them, automatically this configuration will push it. Because if you take the Puppet or if you take the animal, there are two kind of mechanism, guys. So one is for pull based mechanism and push based mechanism. So let us understanding about the pull based mechanism and push based mechanism. So first one is push based mechanism. Push based mechanism. So in the push based mechanism, so we don't have any agents, agentless architecture. Agentless architecture. So in the agentless architecture, what will happen here? So you should not install any physical agents here. Okay, because this is a cluster, right? So someone will monitor, right? The master should monitor in all the servers. So how they can able to monitor? So they need to use some kind of agents here. So they need to use some kind of install, some kind of software or any package should be required to watch each and everything. So if you don't have any agent, they are using the SSH. Master will use the SSH protocol. So SSH is nothing but connectivity. Okay. If I want to log in one server to another server, automatically we can go for the SSH. And this configuration is nothing but okay. So this SSH configuration is nothing but agentless architecture. This is the agentless architecture. So this is agentless architecture. And the same way, guys, whenever if you are install any agent, that is called it as a pull-based mechanism. This is called it as a pull-based mechanism. The pull-based mechanism. So then it will call it as a agent architecture. Agent. So what is the agent here? Any software or any program we can just install in all the servers. So whenever any changes are applied here in the master server, automatically it will be take it. That is called as a pull-based mechanism. So this architecture is nothing but agent architecture. So you need to make sure agent should be up and running. Agent should be up and running, guys. Agent should be up and running. So whenever the agent is up and running, so then only it will work. Whenever the agent is up and running, then only it will work. So now Chandra, clear this point. So how it should automate it in the DevOps, guys? Correct. So we are using some kind of tools. So by using these tools, we can able to automate it. So here, what is the most important here? Ansible. Ansible is nothing, is a agentless architecture. We don't have any agent. So what will happen? Suppose, okay, today we are going to configure all the configurations on the 100 server. Within fraction of seconds, it should be applied. Okay, after for 4 hours, we are having some issue. So whenever we are having some issue, you no need to worry to log into each and every server to check like where is the issue and what was the issue. We can just revert it back because whatever the configurations we are keeping the configurations into the some kind of repository. So some kind of repository. So this is called as Git. Let us assume we are keeping them into the Git. Okay. So please make sure, guys, as a DevOps engineer, so whatever the configurations we are doing, so all the configurations should be the trackable. Okay. Suppose today we are doing some kind of configuration. So you have some kind of trackability and we have some, we need to maintain some kind of version like where is the issue and what was the issue and how we can able to troubleshoot the process. Clear everyone? Any questions still now regarding the configuration management? So out of here, the Puppet and Ansible is the best tool in the market. But even the Puppet, why I can say the Ansible is very, very important. See, up to Puppet is only up working only for up to 35 modules only. But if you are using the Ansible, so it will work thousands of modules. So by thousands of modules, it can able to access. So this is very, very important. Clear everyone? Clear Chandra, Hema, Praveen, Arun? Can we go for the continuous monitoring now? Chandra, coming to our scenario, right? So initially what we tell, okay, I want to install some kind of 200 servers. Nothing is there. All 200 servers will connect into one single master server. We can just execute the configuration to the master itself. Automatically, this master will either should be push based or pull based. All the configuration. That's it. Your job is done. So for this, you need to learn one technology that is called as a Ansible. So this Ansible we will cover under configuration management. So next one is continuous monitoring. So we can say that the continuous monitoring is we are using organization by organization, they are using some kind of internal technologies or internal tools. But in our case, we are using the cloud to monitor all kind of infrastructure, all kind of infrastructure. The continuous monitoring is nothing but proactively we can monitor. Proactively we can monitor. Let us suppose, so if you take any kind of application, in the any kind of application, we have different types of resources will be there, guys. So I will show you a typical application, how the flow will be there, how the flow will be there. Let us assume, so we can take any kind of application and I will explain to you from login to logout. So how the application will be there, and we can understand that, and these are the services. So we are going to monitor. These are the services we are going to monitor. So this is very important, guys. So let's come to here. I will show you a small example. Let us assume, okay, let us assume, so we are having Amazon, okay, Amazon application. So in this Amazon application, so this is very, very important, guys. Okay, if you understand this flow, so you can convey same flow to your projects in the real time. So how it should work. So Amazon, if you are whenever if you are accessing the Amazon.com, www.amazon.in, Amazon.in, so automatically it should go to the Amazon site. It should go to the Amazon site, and we need to get the orders details. Get the order details. So this is our agenda, guys. So this is our agenda, and we need to understand and what are the resources and what are the services and what are the layers are available in that. Okay, so we are going to explain this concept. Okay, so first of all, we need a data center, right? So it should be cloud data center or virtual data center is required. So where we can require the server. So in the data center, there are two kind of resources will be there. So one is for public and another one is for the private, guys. So let's create, I just created this one. Okay, I just created this one. And here I can mention like this. Oh, yes, okay. So I can differentiate like this. Right. Okay, so this process is nothing but public network. So in the organization level, we can call it as in the organization level, we can call it as DMZ. Okay, DMZ we can call it the dematerialized zone. Dematerialized zone. Okay, so DMZ stands for dematerialized zone, and there is a this is called as a public, guys. Okay, public network. And one more thing, so this is called as a TZ. TZ. Okay, so TZ stand for trusted zone. TZ stand for trusted zone. So one is for DMZ, dematerialized zone, and another one is for the trusted zone, right? So here, what happened in the public environment? In the public environment, in the public environment, so we are deploying our applications. We are deploying our applications as public resources, guys. Okay, let us assume so all the web servers. So here I can differentiate like this. Mm, okay, fine. So this is the server one, server two, server three. Let us assume why we already know that, right? We already know when we discussed the continuous delivery. So we already know that. So why we are using more than one server. So for more than one server is help us for high availability. For high availability, so we are using for more than one server. Correct? For more than one server. Let us assume so web server. So let us take this is for web server one. This is for web server one. Web server one. Web server two. Web server 3, right? So we have the web server 1 and web server 2 and web server 3. So what are the web servers are in the market, guys? So web servers are in the market, guys. So there is a web servers in the market. Either it should be, either it should be HTTP, Apache, or Nginx. So these are the servers are in the market. So these are the web servers are in the market. So please make sure, guys, in the organization level, there are two types of the servers. So one is for web server and application server. So the web server will help us. Just we can transfer. We can serving the static application. Okay, to keep the static application. So let's see like this, like this, like this. Okay, so this is called as the static application. So what are the static applications? Are nothing but it should serve the static content, right? So it should be HTML pages, all the HTML pages are etc. So this is the static pages. So as of now, clear? So there is a tool in the data center. So we have two types of environment. One is for public and another one is for the private. So the public is nothing but DMZ, dematerialized zone. Okay. So whenever we are getting the request, right? So how we can able to transfer how we can able to get the request, how we can, who is the responsible to transfer this request to these many web servers. For web server, we know that directly we can, if we have the web server URL and we can directly hit it. But in our case, we have three web servers, right? Within the three web servers, how we can able to distribute the load? How we can able to distribute the load across these three web servers? So in that scenario, so we will go for the load balancer, right? So we will keep under load balancer. See, this is very important, guys. So this is called as a load balancer, right? So let us keep. This is called as a load balancer. There are two different types of load balancer, guys. Okay, so application load balancer, network load balancer. Okay, application load balancer will transfer in the HTTP. Network load balancer nothing but data center level also we have. So because suppose let us see, all of a sudden if one data center is crashed, so the request will go to the another data center, so that is expected. So this is how that is an, if you take 99% of the organizations are, this is the same flow, guys. Okay, if you take like this now, so automatically, what is the responsibility? What is the responsible for load balancer? There are two things responsible for load balancer. So first thing is, to distribute the code, distribute the code, distribute the traffic. Guys, sorry, distribute the traffic. And second one is to check the health checks. To check the health checks. Suppose all of a sudden, if any server is down, right? If any server is down, automatically the load balancer will not sending the traffic to that affected server. Okay, the load balancer will not sending a traffic to the affected server. Now like this, like this, like this. Clear, everyone? So here we have the web server. All the web servers are in the HTML pages. All the web servers are in the HTML pages. Now this is the load balancer, and we have the distribute the traffic and as well as to check the health check of the system. So this is very important, guys. This is very important. And before that, we need some kind of security, because whenever we are, some gatekeeper is required, right? So we are the data center. We are managing so many resources, right? So who is responsible to make sure to the request is correct or not, the request is correct? So that's why we will go for the firewall. So for this we will go for the firewall. So this is called as a, let us assume this is called as a firewall. So this concept is, this is called as a firewall. Okay, so what firewalls can do? So it can only having the inbound and outbound traffic. See, whatever the traffic, right? Whatever the traffic we are getting to our data center, everything it should be tracked. Suppose we are sending, suppose someone is trying to sending the request to browser. So the browser is which protocol? HTTP protocol, right? So in firewall we need to configure HTTP. Okay. Suppose there is a data center inside the server is there. If someone is trying to log into the data center, that is the SSH protocol, right? And if anybody want to log into some kind of database or anything, then we have some other protocol. For every resource, for every service, we have some data, We have some port configuration is required. So without port, we can't able to, the firewall will not able to allow the traffic to inside the data center. So this is guys, okay. Now we will test it. So as of now, we will test it, okay. And suppose the Chandra is trying to access the browser. Chandra is trying to access the www.amazon.in. Okay. Whenever we are hitting the www.amazon.in, whenever we are hitting the amazon.in. So what will happen here? So automatically the request will go to this data center. How? How the Amazon, how this server knows, how this request knows, the request will go to this data center only. Let us assume, I can show you practically. Yeah. So I just click on the amazon.in guys. Okay. I just click on the amazon.in. You see, I just click on the, I'm trying to, yeah, I'm just trying to sign out the things. Yeah. Okay. So amazon.in. See, right now I didn't log into the amazon.in guys. Right now I didn't log into the amazon.in. Still I can able to access this application, right? Still I can able to, even I don't have any account in the amazon.in, still I can able to get the access. Still I can able to get the access, right? So this is the HTTP. This is the HTTP and SSH request, right? So the load balancer and distribute the code and it should be moving, right? So when we are hitting the browser, how the browser knows, our browser knows the request will go to Amazon. Why the URL is not going to Flipkart? Why the URL is not going to some other site? Because they are using some kind of mechanism, some kind of DNS configuration. So this is called as a DNS configuration, domain naming service, DNS. Okay, DNS. Okay, in the DNS, what it contains? So there are a couple of records are available. That is the SOA records and NS records, naming service record. What is a naming service record? It will communicate with entire internet around the globe. Around the globe, it will be communicated to internet. Okay, just see, our my intention is you guys don't want to buy hard or anything, just understand the process. Even you didn't understand, even you didn't understand the terminologies or anything, just you can listen one more time the recording, right? If you know the process, okay, if you assume that, so as of now what you assume, okay, whenever we are hitting the amazon.in, so directly the request is going to the, site, but no one don't know, right? If anybody asking the question, so what is the internal flow, so how it should work, but no one don't know. But as after completing this scenario, after completing this diagram, you have some idea. So what are the resources are available in the application level, what are the resources are available in the middle layer, what are the resources are available in the front end layer, right? So the DNS record can contains, yeah, DNS records are available, right? The DNS records can contains automatically internet. Okay, once there is a hosted zone. So in the DNS domain naming service, where we need to host our application, whether it should be cloud based or non-cloud based. So we already know the GoDaddy, right? You might be heard about the GoDaddy. So in the GoDaddy also we can host application. In the cloud also we can host application. If you take the cloud, they are Route 53. Otherwise, you can go for the GoDaddy, right? So after that, after the DNS, everything is okay. Automatically, it should communicate with the internet, right? Once the communication internet is happening, so in the hosted zone, it will check what are the address records are available. Okay. Sorry, sorry guys. Please mute yourself. Okay, right. Okay. So automatically, once the DNS is there, we can understand where is hosted. It should be public or private hosted. Okay. Then after that, so the request will go to some kind of hosted zone, yeah, in which hosted zone is available, and it should be different types of records are available, address records or alias records. Yes, so alias records are nothing but, so your domain, right? So www Amazon.in, will pointing to the load balancer URL, load balancer. So you should not see these details, guys. Only the organization level we can able to see these details, the route 53 and everything, where you are hosting our application. Okay, load balancer, right? So what this is the load balancer URL, right? Automatically the request will trying to go to the load balancer. So if you are trying to go to the load balancer here, if you're trying to go to the load balancer here, it is exporting, correct? So the firewall is available. So what is the firewall here? So this is the securely layer, securely layer. So it will keep track all the traffic. So whatever the traffic is coming to the data center, whatever the traffic is not coming to the data center, so that is called as a firewall. That is called as a firewall. Yeah. So now it is accepted. Then the request will go to the the load balancer, guys. So the what load balancer can do, it will be distributed. That's why you are getting this page every time. We are getting, if you hit 100 times, 100 times we are getting the same response, because this is a static page. Because this is a static page, you no need to require to log in. You no need to require to log in. Still you can able to browse this, because this is the static pages. This is the static page, and this is coming from the dematerialized zone. This is coming from the public hosted zone. So next one is the trusted zone. Okay, I am fine. So now what I can do, I am going to log in, right? So I am going to log in. If I click on the login here, if I click on the login here, yes. If I click on the login here, yes. Okay. So I am trying to log in that. Okay. Oh, yeah. So I just logged in there. Now, once I log in, my application is converted. Okay. So it should be authenticated. Earlier, did you remember when I hit the wrong credentials? It is not allowing inside. It is not allowing in. So who will responsible? But this web server will not responsible. This is the request will come to trusted zone, guys. Okay. This is a high secure layer. Okay. The private connect, and here the actual applications is available. Actual application is available, guys. So this is called as a application layer. So like this. So this application might be designing, either it should be Java application or .NET application or PHP application, any of the technology. Okay, let's take, this is the application server. So application server 1, application server, app server 2, and we have the app server 3, app server 3, app server 1, app server 2, and app server 3. So what it contains, this application, this is called as dynamic application. So here the dynamic applications will come into the picture. Dynamic applications are nothing but the applications which are developed based on the request, guys. So whatever the request we are giving, so automatically the response will be changed. The response will be changed. So that is called as a dynamic request. Okay. So, and apart from that, there is an application load balancer is there. So we can also keep the application load balancer. Let us take, so this is your application load balancer, right? So this is your application load balancer. So what will happen if you're using the application load balancer? Okay. Yeah. So this is your application load balancer. See, you might have one doubt, sir. Directly, why can't we go for directly trusted zone? The request will not go to the trusted zone, because this trusted zone resources only access within the AWS Amazon network. It is not working in outside the network. Okay, so that's why we are hitting the URL to the DMZ zone. So because it is available in the internet, it is available. So here also application load balancer. So now you have some kind of conclusion, guys. So whenever we are using the more than one server, we need to require the load balancer. load balancer. Like this is called as a application load balancer, ALB. So this call it as a application load balancer, right? So what application load balancer can do that? The application load balancer will automatically distribute the traffic. It should be distributed the traffic like this, like this, like this. Correct? Na? So this it will be automatically to distribute the traffic. So this is called as a application load balancer. Now coming to here, so automatically we send a request, right? Whenever I am hitting that username and password, okay, the request will go to the web server will trying to get the request to the here load balancer. How we can do in between? There is some kind of in between. So there is required some kind of network is established. Okay, so this network is nothing but private network. Okay, this network is nothing but a private network. So what is the meaning here? The private network. Only this network will help us. Only this network will help us inside the premises, inside the resources, inside the resources. Outside people will not able to access these resources. Outside people will not able to access the resources. Clear? So this is called as an application load balancer, and automatically, okay, the based on the request to the application. The application will trying to get the database, right? So we need a database is required. So without database, nothing is there, right? Without database, nothing is there. Correct? So this is called as a database. Yeah, within the database. Yeah, within the database. Yes, within the database. So it can contains customer ID, customer ID, ID and password. Okay, so whatever the enter I am using. So let's see ABC and password is like this. Okay, so clear na? So whenever we are hitting the password, automatically the request will go to dynamic because it should be there in the database, correct? It should be there in the database. It is not there in the web server. It's not in the web server is transferring only for static pages. So this is called as a database. Right? So the request will come into the automatically the request will come into the database. So whatever the request is coming should be connected to the database, right? So if it is authenticated, right? If you are having the proper details, then should if it is not getting proper details, then it will transfer to the error pages because immediately the request will do like this. Request will do like this. Okay, the request will do like this. Two-way communication, right? All the two-way communication will be established. Correct? So after that, the request, if any something is wrong, if any error pages are wrong, automatically the request will go to the who will server? Web server will serve to the error page. This is called to the error page. Error page if errors. Suppose if you get any request, automatically it will go to the browser. If any success, automatically it will go to. So this is how the terminology, guys. Clear everyone? At least I hope I gave some kind of idea. So how it should work internally in any kind of application. Same thing you can convey to your organization as well. So let us see the flow of execution. The first one is the first thing. The user, the first request, the user will hitting the browser. Whenever the user hitting the browser, that is called as a domain. So this call it as a domain, fully qualified name. Okay, domain. So automatically the request will go to the hosted zone where your application is hosted. So based on the DNS, the request based on the NS record, the request will go to the hosted zone where your application is hosted. Where your application is hosted. Now I can do like one thing. I can do one thing like this, like this. Okay. So let's make any other color. Yes. Okay. The first thing is first thing. So whenever the end user trying to hit to the browser like www.amazon.in, So automatically the request will go to the DNS based on the domain naming system, domain name, the request will go to the DNS where the hosted, and based on the alias name, So this is called as a second one. So based on the alias name, the request will go to the alias. There are two things, guys. Suppose if we have only for one server, so that is the address record. If it is alias name, I will explain to you. Don't worry about it. So how it should work, the domain, everything will come under AWS in the AWS session. So please make sure, guys, since 2 days, so we are only discussing for theory. So don't think this is only for theory. So it will very helpful for it's a boost up for your coming classes, because so after completing for today's class, everything should be the practical. When we go for the practical, so we have a lot of POCs, lot of environments will be there. We can able to install it and we can able to do that. Okay. So once Amijan, so based on the request will go to the firewall. So the request will go to the data center, correct? So once the data, it will go to the data center, the firewall will be validated whether the request is trusted network or not. Whether the request is trusted network or not. Let us suppose if the request is not a trusted network, then automatically it should be denied. Okay. If the request is okay, sorry, if the request is not trusted network, it should be designed. If it is trusted network, then it will allow inside the data center. It will allow inside the data center, right? So the what load balancer can do that? The load balancer will take the request and distribute the requests across all web servers. Okay. So here we can take like this. So this is called as a sixth one. Okay. Next one is we can go for the web server. So we can able to serving the web server. Once the web server is coming, automatically based on the request will go to the private connectivity. Again, it will request go to the application load balancer, and the application load balancer will go to the application to the dynamic application. So dynamic application. So this is called as 9th. So based on the entry, because this is the business logic, guys. Okay, the databases will be there. Based on the databases, the request will go to like this. And finally, whether it should be success or not, it should go to the output. Okay, output to the browser is 11th. So clear, everyone, or any confusion here? Chandra, Hema, Praveen, got it? Clear for understand? So regarding what are the resources and how it should be there. So in the continuous monitoring side, so what is our agenda? The DevOps engineer will do some kind of automation to monitor all these resources, guys. To monitor all these resources. So what are the resources you should monitor? So first one, in the DNS level, you can able to monitor whether it should be getting or not. In the network level, you can able to monitor the public connectivity and private connectivity. If we lost any kind of connection, we proactively verified and we can work on it. And the load balancer and application load balancer and web servers and application servers. Okay, you might have that. You might have one application server. The application servers will serve only for the dynamic applications. The application load balancer will serve only for the dynamic application. So here, what are the application servers are in the market? Tomcat, WebLogic, WebSphere, JBoss, etc. So all the servers are connecting application load balancer. Clear, guys? So that's all from today's class. So next, what we can do? So we are going to directly jump with the first tool in that is the Git, the first tool in the continuous integration. So we will see in the coming session. So any questions? Chandra, any questions from your end regarding this diagram for today's class?
No.
Clear?
Yeah.
Hema?
Yeah, clear.
Praveen?
Notes, sir.
Sorry, Praveen?
Notes,
Okay.
notes.
Okay, fine. So thanks, guys. Thanks, everyone. So let's see for today for further class. Bye.